Hello, Professor.
Hello, hello.
Just so you know, Professor, it's snowing and cold here.
Oh. But the school is running.
Oh, yeah. There's not that much snow.
Yeah.
Dr. McWally,
Yes, sir.
I have Cameron in my office. Would you mind if he demonstrated for us a test bench for homework number 5A? There's several of us that were having troubles with the test bench for that.
Okay. Okay. He may share the screen.
Okay, I will do that. Thank you.
But I want him to start from scratch, if possible.
Instead of pull up the one that,
I mean, we are starting a new program. He has the two programs, I am sure he is. So I want him to start from scratch. That means generate a subfolder, and this subfolder, he will give it a name, and then we'll start an empty project, and then he can copy his program into the new VHDL file. I don't mind that, but I need for everybody to understand what's going on to start from scratch.
So is he saying the program or the test bench?
Test bench.
The
You can copy the program and you copy the test bench, but you should show the students or show everybody how to start and how to compile, how to add the new file to the project and all of this stuff. Ready to go?
yes, we were just discussing it. I'm going to leave the mute off so he can be talking as he does it, and you can interrupt if you wish.
Okay.
And you'll need to
share screen.
share screen.
Is that sharing this? Oh yeah, that's the right one. Okay. So we got our file here, which is in this, you tested this works as of right now? Oh, you don't know? Okay.
Well, I tested it with the waveform generator, but I haven't done it with the test bench.
Well, did it look good with the waveform generator?
I thought so, but
Okay, well,
It's very different.
yeah. Okay, well, it should, if you have the, oh wait, there's no button push. Okay, yeah, we're fine. Okay, so since we already have our thing written here, I'm just gonna make one from scratch and not go up. There's a way you can do this where if you go to start, where is it? Processing, start, and then go over to start test bench template writer.
That's good.
And what was that?
Yes, great. Go ahead.
Okay, you're good with that? Okay. I'm just gonna click on that. There's a way you can also do it with the VHDL file, with just making a new file, but I'm not gonna do that. And if you notice, if we go over to files here, we go to hierarchy, and then go down to this drop down menu where it says files. You'll notice there still isn't a .vht, like VHT, not D. And we want to make sure we're looking for that VHT file. So, and we don't see it here. So we want to go up to do is go up to project, because we know we just pressed that test bench template file thing. So it should have made a VHT, but we don't see it in our project. So if you don't see it, you got to go up to project, add remove files in project. And then you'll see there's no VHT file in any of these. So we got to go up to these three dots here. And then wherever this, so there's going to be an output directory here where it says generated Verilog test bench file, C, users, James Ballard, OneDrive, all this whole thing, right? And it should have made .vht. Now it looks like it made a .vt, and I think I know the reason for that. So hold on, let's cancel this. If you look down here, it says .vt. We want it to say .vht. So .vt is for Verilog. And so we are not using Verilog. So what we need to go is up to settings again, go to EDA tool settings, simulation, and make sure that this right here where it's set to Verilog HDL is set to VHDL. And then press apply and OK. And the reason we did that is because it made a test bench that was in Verilog, and we don't want a Verilog test bench because we're using VHDL. So what we have to do now is go back to tools, or sorry, processing, start, and use the test bench template writer again. And this should make, give it a sec. And there we go. Now, if you look at this right here, it says .vht, and that's the important part. Okay, so now that we got that, we got to go back up to, where was it? What were we doing? We were doing adding the project, because if you notice, there still isn't a .vht file here. So project, add remove files in project again, three dots. And now we'll look at the output directory. It looks like it's in simulation model sim. So we'll go simulation model sim, and you notice there's nothing here because our thing down here is set to design files, but we want it to be .vht. And so we go to test bench output files, and there we go. We have our VT, which is the Verilog one, and then the .vht. So this is the wrong one. Don't click on that. It has to be a .vht. So click that, open, and then it should be up here. Make sure it's the same file, add, and now we have VHDL test bench file, and it should give you the output directory where that file is. And then we go apply and OK. And now you notice here in files, we have the file right here. So we double click on it, and now here's where it wrote all our test bench. And I'm just going to separate this out because sometimes these can be kind of hard to read, especially when you got a long name like slow clock to fast or slow to, yeah. So I just like to clean this up because the way it writes it is kind of, I guess, hard to read. So we'll go ahead and separate this out. And so what this did here, when this was writing this, and I think most people get this, but I'll explain it again, is that, oh, sorry, this one should go back. These are all, actually, yeah. Let's do that. There we go. Okay, so this, first you declare your component, which the component is the same name. This should be the same name as your entity from this, wherever you declared your entity. So here where it says entity, slow clock to fast clock, and you have all your port declarations, that should be the same name as this component declaration. You can literally just copy this whole thing and write component here and component here, and that's all you got to do, or here and here, just to be clear. And that just says that we're using this entity from this program, this entity right here. It's included in this file list. The Quartus will automatically like include it when you just put the same name. So we got that. Now what we do is we instantiate the component. So we told the file that there is a component and it has these inputs and outputs. but we didn't say what those inputs and outputs actually correspond to in your signals up here. So that's why we just changed them here. And so that's how this is formatted here. Okay, so now we got that. And now we're starting a process called initialize. And this says code that only executes once. We really don't care to do that. We're not writing any programs that need an initializing thing. So we're just gonna get rid of this part where it says wait, because that wait is what causes the program to just stop and only execute once. So we'll get rid of this. And we shouldn't need any variable declarations because we're not doing anything involving variables inside our test bench. And so we can just move this back up here. I just like formatting it like this because it's easier for me to read. And then we'll call this first process clock because there's a clock. There should be a clock A and a clock B. So we'll call this clock A. Clock A. There we go. And so now inside this process, we don't want a sensitivity list. We should just want like inside this process. Usually we'd in any other file we'd have a sensitivity list with like a clock or something like that. But we don't care about that here. We don't want, make sure there's no sensitivity list there. Because if there is, it'll screw up your program. So I know I made that mistake a lot. So now we're at clock A. We can go, we want this to stimulate the clock going up and down. So we'll go, and let's see, this clock is called clock A, and that's going to be equal to not clock A. And then we're going to wait for, in the program, it says, I think, what's it supposed to be? We're just going to call it 25 nanoseconds. And I think there was a time in the program for this, for the parameters that we were supposed to put this to, but that's okay. We can just call it this. And now we just need to copy this because remember we have a B clock too. So we have another clock that we need to keep running. So let's go ahead and just copy and paste this whole thing at 11 megahertz and clock B at, okay, well, we'll just make clock B a shorter time.
No. Yeah. One's at 11 and the other one's at 100.
Right. So now clock B, and so this is clock A was at 11 and clock B, so we'll call this like 10 nanoseconds.
No, which, okay.
It's just so one clock's faster than the other. It really doesn't matter that much. Okay, and now we'll here, I'm gonna do this. There we go. Okay, and now make sure this is the same process. Clock B. Okay, so you notice now we have two clocks that are running. One's going to change, or one is running at a period of 50 nanoseconds because it's double this time, and one's running at a period of 20 nanoseconds. So you can go ahead and see whatever that frequency is. But in the real case, you have to go in and say, okay, well, this one's running at 11 megahertz, so I need to find the period of that and then divide it by 2. Because remember, this is only changing, this is only half a clock cycle right here. Because it's going from high to low. So just make sure you remember that. All right, so now in this process, we want this this next one to actually like do something to the inputs of the process. If you get rid of these tabs, it'll look better. Sorry. I'm all about formatting here because I like it to look like the way I want it to, and it's easy to read that way. Other people are not. If you don't care, it doesn't matter. Okay, go back to begin. Okay, so now that we're here, I'm going to call this process stim. That's generally what I call the ones that are for making the inputs change. And so now we go over here and we're going to, let's see, what are the inputs we want? I'm just looking at, I don't think the camera's on, but I'm just looking at the timing diagram that's on the homework 5. If you look at the back of that page, that first page, it should be a timing diagram. And let's see, we have a reset. Why do you have a reset out?
Oh, I was just looking at it on the, you can ignore it. Don't put it on the.
Oh, it's an output anyways, so yeah. We can just ignore it, I guess. Okay, so we have clock A, clock B, and reset. That should be the only things. Mm-hmm. So let's just set reset high for the first. I don't know. Let's see. We have a process. We have a 15 nanosecond clock. So let's make it for 5 clock cycles. And so that's what, 250 nanoseconds. Reset equals 1. And then wait for 50 nanoseconds, or sorry, 250 nanoseconds. Reset equals 0. All right, and now the rest of it's just going to run by itself because we have that counter in there that's just going to count up every time. And so now we can just do, what we have to do is if we just do this, after 250 nanoseconds, the reset will reassert. And so what we have to do is we have to put some really long time. We'll just make like much longer than your clock cycle. So we'll say wait for, let's see, a 50 nanosecond clock cycle. Let's do a 10 microsecond wait time. And then we're going to do std.env.stop. So the difference between this std.env.stop and your, oops, do that, and your wait are that wait just stops this process from happening. But std.env.stop will make the entire program stop. It's like putting, if you ever use Visual Studios, it's like putting your breakpoint in there like that, right? Where you get that little red dot next to the line, and it will stop the entire program. And that's kind of what we want. We don't want it to keep going after 10 microseconds because we don't care what the output is. So if you just put wait, you can, I don't like using wait. I would rather use this std.env.stop because if you make this time long enough, it won't matter. And so anyways.
I have a remark here, please.
Yes.
In the process clock A
Yes.
and the process INIT in
Oh,
it.
Yep. Thank you. I see that. Thank you. And I think
Clock underscore A small. Yeah. Thank you.
Lowercase. Yeah. You're right. And I think that's everything we need to do for this one because we only have 3 inputs here and all these other are outputs. So we should just be reading them. So I think at this point we're ready to run. What we have to do first is go up to assignments, settings, and go over here to simulation. We have this at VHDL, which we checked before. Make sure this tool name up here says Model Sim Altera. And then go over here to compile test bench. Click that. Test benches. New. And then over here where it says file name, there's going to be 3 dots next to it. Click that. And now we should be in, if you made a separate file for like a separate VHDL file and then made it a VHT, it'll probably be here. But if you use the test bench template writer, you have to go to simulation. It's usually here in Model Sim, but it might be somewhere else if you set your directories different. So make sure you click on the .vht file, open that. And now it's going to ask you for a name up here. Just name it the same thing. You can literally just copy and paste that without the extension. So no .vht on that. And there you go, slow to fast clock. Now press add over here, press OK. You should see slow to fast clock or slow clock to fast clock and press OK. And now you should see that here, slow clock to fast clock. And that's our test bench. So now we press apply and OK. And now we should be ready to run our simulation tool. So go up here to tools, run simulation tool, RTL simulation, click that.
We don't have to compile.
Oh, oops. Yeah, he's right. Sorry. We got to compile first before we do that. Give it a sec. Let this thing open up or else this is going to take forever. Yeah, it's not going to like it if we don't compile that. Because if you look, since we didn't compile, here, I'll show you what happens if you don't compile. Hold on, let this thing load for a sec. Yeah, it doesn't like, this is why it didn't like that we skip messages. It didn't like that we didn't compile and it's still trying to run the test bench. So here, we'll close this out. Sorry about that. Close all this out. All right, now we'll go ahead and save, compile. Give it a sec. It's going to take some time. Any questions on any of that?
That was fast.
This fast?
But I guess if Dr. Amr saved it all, we can look at it.
I was going to say, if you go up here to assignments and settings, and Model Sim Altera. And if it's not this, you should probably check over here in Tools. And I think it's, where is it? Is it Options down here? And down here where it says EDA Tool Options, and make sure that this says C Altera Lite 16.0 Model Sim ASE Win32 ALOM. That's the most important part. Make sure to select that file. Because if you don't, it won't run. So that one was already set for us, but if this is the first time you're using the test bench, make sure you write that. And so now 0 errors, 70 warnings. So that sounds good. We're at 100%. Okay. Now we just got to go up here to back tools, RTL simulation. Now let this the test bench thing or model sim load up. All right. Let's see here. Give it a second to do its thing. And now it says errors 0, warnings 1, but we'll see if that's actually right. Invalid error, invalid command name. Okay, so since we put that test bench to compile, it just automatically simulated it, which I don't like that it does that because mine doesn't do that, but for some reason his computer does. And so what I like to do is I just like to go down here and make sure that this is okay. It doesn't look like their test bench is here. That's weird. Let me look through here. Of course, it doesn't want to work as soon as we're recording, but so we called this slow clock to it should say simulation something or other. Let's see. VHD test. Is that the same name as the? I'm gonna close these simulation. Slow clock to fast clock VHT. Let me see. This is the same name. Yeah, thinking.
It's not there under work.
I don't see it. Hold on. RTL. I think it's VHD test. What is that? Did you make that? This VHD test?
Yeah, that's the variable wave. That's the variable waveform.
The waveform generator?
Yeah.
But that shouldn't be it wouldn't have shown up if it was the waveform.
Well, run it.
Let's see, where does this say it is? Okay, this is the VHD. Okay, see, so now that we pulled out the files, you can see where at the very end here, slow clock to fast clock.vhd. Okay, this is what we got to recompile. So recompile that, and now see we get 0 errors, warnings 1, and that should be, and see, it gives us this error or this warning where it says package std.env does not exist in this language version. If you got that, that means you used your right std.env because that was in there. So we know that if we're getting that warning, it has to be that same test bench file. Okay, so now we got that. So we right click, we already recompiled. Just always recompile, even though it should have compiled it at the beginning, because sometimes it'll give you errors and weird errors, and you just don't want it to do that. So right click that, press simulate. This operational, yeah, because we don't want whatever simulation it just pulled up, because we don't really care about that. So give it a sec. It takes some time because this program's like 1 million years old. But okay, this is not what we should be getting. If you get something like that, so see, it should have your, oh, here we go. Never mind. This is what we should be getting. See where it says I1, because that was the architecture that we had. If you look down here, we declared our component as I1. And so the component here should be I1, whatever that name is, whatever you called it. I usually call it device under test or DUT, but you can call it whatever you'd like. So whatever that's called, you're going to click on that. Let's add wave. Do not add wave to this because it won't show you your signals. It'll only show you the inputs and outputs, but this will show you your signals and like the actual internal signals. And that's important for debugging. So you can actually see what's going on. So press add wave to that. And then we'll go back over here and we notice that is a lot of stuff. Is that all of, oh yeah, okay, that's everything. Okay, so let's go ahead and change this. We set our end time to 10 microseconds. So let's send this to 10 microseconds. That should be a little less than our end time. And we'll press run. Okay, now here, I'm gonna make this full screen over here so you can actually see this. If you notice, there's a lot of red and there's all these U's, and that means that this was set, even though we reset this, here, hold on, let's zoom out here. We should have a clock. Where's the, oh, Nope. So you notice our reset goes high. That's what we set in our test bench, but everything else is red. And what that means is that we didn't initialize the values. And so when it's trying to do stuff with it, it doesn't know what to do, or the test bench doesn't know what to do. So what we got to do is we got to go back through and set all our signals originally that we set over here to 0. So right here, everything here, we just got to set to 0, initialize to 0. So we'll go equals 0. Oops, 0. I'm just going to copy and paste this for the rest of these. Oops. All right, and now this one I'll do other 0. I can't remember the syntax for this sometimes, but is it that or is it the other way?
It's that way.
It's that way? Okay. If someone else knows that, I can't remember. It'll either give us an error or it won't. Now, when you do this, you recompile here, and then you also have to recompile here. So we'll go back over. Sorry. Because there's two different compile, and I'm pretty sure that the Quartus compiler will only compile your .vhd, and so if you change this, you got to compile here. But if you change this, I don't necessarily think you have to compile here. You can just compile here, but don't take my word for that one. That I don't know about that one. You should just compile just to be safe, even though it takes some time, and I know it's annoying to have to do that after every time you change something. But I noticed one thing you can't do is whenever you change this, your actual VHD file, you need to go in and restart ModelSim. Like close this all out and go back up to tools. But if you just change your test bench, you can just recompile here and then recompile in ModelSim. You can keep ModelSim open though. So I'm gonna go ahead and close this wave out because we don't really care about that. And now our compilation was successful. So we go back here to our library, right? Where we had our original file, right click it, recompile. Give it a sec to do it. So, okay, now what's it? Okay, so it doesn't like, I think I put them the wrong way. Put these the wrong way. That's why it's giving us that error. Okay, let's save, compile that again. I'm sorry, again, it takes some time. I'm gonna close some of this out. Give it a sec to do its thing. Yeah, you notice like it didn't catch those errors. Like this compiler did not catch those errors. And that's why I think that this compiler is only compiling this part and not this part. But I don't know that for sure. So just compile every time just to be safe. Because sometimes it will catch errors in this and sometimes it won't. So it's just weird about it. Yeah, Quartus is weird.
Very complicated program. I mean, it has a lot of stuff in it.
Yeah.
What I meant.
And the paid version is even more complicated. You can get like they have ones where you can simulate the actual FPGA you're using, and it's really cool. They have a lot of cool stuff in here. Okay, so now this is done compiling. Let's go back over here, and since we just changed test bench, we can just recompile. We don't have to close this out. So recompile this, and now we get error 0, warnings 1. Perfect. That's what we expect. Go back up here, right click, simulate. Same thing we did before. Yes, close the current simulation. All right, and now we go back to I1, right click, add wave. Oop. Go back over here. I'm going to make this full screen. Okay. So now that we got this here, and I'm going to change the time again to 10 microseconds, and we'll run it. Okay, now we still have these red lines that are saying you. Yeah, let's see why is that? Why is
Could be an error in my program.
It actually doesn't look like this changed at all between the two. Yeah, this is weird. I am going to close this out. Let's close this whole thing out. Now we're getting this error. Let's go back to the original file and make sure all of these signals are initialized to 0. So all of these look like they're initialized to 0. Let's initialize these ones to 0 too. Zero. Okay, and save, compile. let that do its thing. And now we're gonna have to open ModelSim again because we actually changed our VHD file, not just the VHT. I'm trying to look at it if there's any. That's right.
Go to the very end, there might be something. I took that out, so it's all right.
No, okay. TX data out. Wait, why is I don't think you ever said.
You took the reset out.
Oh, okay. All right, 0 errors, 0 warning. Oh, nope, it's not done. Still down here. Okay. All right, perfect. So now that we've done with that, let's go back up here to tools, run simulation tool, RTL simulation. Give it a sec to start back up. Just take some time. Okay. 0 errors, perfect. So now we'll click here. Oh, skip messages. Yeah, I don't know why. See, this is the error that I was talking to you about earlier, where it's
Right.
like it just gives you this. I don't know why it gives you this. And this I think is let's see. I don't trust that to be the actual one that we're supposed to be using. So I'm gonna go back down here to work. Like I said, always recompile this just to make sure. Make sure it says 0 errors, warnings 1. That's normal. Simulate. Open that up. Component name, add wave. Go back to the waveform generator. Okay, so now we got the waveform generator up again. And okay, I can already see we're gonna have a problem with acknowledge A and request B. So it looks like, oh no, actually those should be set to U. And so should reset out. Okay, that's fine. As long as the rest of them are set to 0, I think we should be good. Let's go here. Okay, that's looking probably a little better. Now, it doesn't look like our clock is changing at all, and that's weird. Why is that happening? Because clock A is what's happening at the beginning here. It looks like something's happening. But then the rest of the states are, yeah, so it starts out at 1, and then it's indeterminate past them. And that's weird. Do you actually want me to go through and debug this, or do you want to just,
No,
if
as
just
long
show
as
how
they
it-
see, but I don't see why the clock isn't changing.
yeah, I don't know why it's not changing either. I mean, it looks like it's trying to right here,
Mhm.
and then doesn't, and I don't know why that is. Maybe it's because resets. Oh, no, reset shouldn't have done anything to it.
No,
Oops, what happened there? Which is that? Yeah, I don't know. So you have to go back through your original program and look at what's wrong with it, because there's probably something wrong in the. Because it doesn't look like the test bench isn't wrong. It's exactly how I've done it in the other ones. I just never had a problem with it before, as long as you set this to 0 the first time. So I don't know. I don't know what the problem is. I don't know. Is anyone on Zoom now? I don't. Resets 1. Wait for 2. There's nothing wrong with it. Let's see how
a
you.
clock is a clock. I don't see how it could not be. That's good enough. I'll look at the program and see why clock isn't changing. That is weird though.
Yeah,
I
it
don't
is.
see anything wrong with the test bench.
Yeah. So I think there's probably something wrong in this program that's causing it to be undeterminate somewhere in here, because it looks like clock B doesn't change at all. So there's definitely something inside your program that's doing something to clock B, because clock B should be
Going up
changing
and
based
down.
on, yeah, it should be changing based on our test bench here. So like
Well-
based on 10 nanoseconds, every 10 nanoseconds, it should be changing.
Is that the right time?
But it shouldn't matter. Yeah, I don't know. Just go back through your program and look through it, because I don't see what's wrong with it right immediately. So
Okay, do you have a lecture? Do you want him to do something more, Dr. Amir?
No, I believe we have seen now how to make a test bench, and I believe you followed the handout I gave to the letter. It is perfect. Okay.
Great, thank you.
Could I stop sharing so I continue the lecture?
Yes.
This is our third program, parameterized RAM. In this one,
Professor, you're not sharing.
Oh, sorry. In this program, I am using the generic statement. I am saying the data bits and the address bits. So I have here the data bits to be 8 and the address bit is 10. And it is the same program that we did before. Here I'm just saying I am going to use this generic statement. And as you can see here, I'm specifying my RAM type as an array 0 to address bit number -1. So it is 0 to 7. And I'm saying here 2 to the power address bits -1. 2 to the power address bit -1. Of standard logic, data bits -1. I'm saying here 8. So it is 7 to 0. The -1 because I have 8 data bits, including 0. 0, 1, 2, 3, 4, 5, 6, 7. That's 8. That's why I said data bits -1. And this will give me the depth of the RAM will be 1024 and the width is 8. This is our third program for the homework assignment. This is number 3. The first one is the ROM. The second one is the RAM. And the third one is this parameterized RAM. Let's go and double check on that. This homework 6. Repeat the 3 examples presented in class: ROM, RAM, and parameterized RAM. We need those 3. Then part 2, I am giving you different 256 by 8. So you need to change just this one and you will get it run it. So the last one, the parameterized RAM, just change the parameters and it will be okay. And part 3, this is a
Please,
ROM.
can you explain part 2 again?
Pardon me?
Please, can you explain part 2 again?
This one?
Yes, sir.
Yes, I need it to be 256 by 8. Here, in our example, it was 8 to 10. It gave you 1024 by 8. I want it to be 256 by 8. So we need to change the address bits. How many bits to make it 1024? Clear?
Clear, Professor. Thank you.
Okay. And for the last part, I am doing this ROM and I'm storing ASCII code in it. Instead of storing numbers, I'm storing letters. And in this letter, each alphabetic letter or each special character, it has a code number that's called American Society of Code. So each one will have a code. And this code, we are going to store hello, exclamation mark, my name is, and you put your name here, and backslash R and backslash N, new line, and I can add tabs. So those are carriage return and new line. And the ASCII code for those is 0x0D and the other one 0x0D. I want you to read these assignments and start working on them, and we'll continue on those tomorrow in our lab. But for today, we are going to finish our chapter. And this chapter, it speaks next about first in, first out buffer. We spoke a little about it from Digital 2, 133. And the PowerPoint I gave you has this first in, first out. And here we are going to see how this would work and how we may program it. Normally, there are two types of first in, first out. Easiest one if I have single clock for everything. And the other one, it is asynchronous 2 clock domains. I am pushing data in at a certain clock and I'm getting data out at a different clock. Let's see how this would work. First in, first out, I have, for example, 8 memory bits. And I can start storing into those 8 memory bits. When I start storing, I'm speaking about just 1 bit. I need to know where should I start. I would do that by right pointer. This is my right pointer. This is right. And when I want to read, I need another pointer. It is called read pointer. At the very beginning, the right pointer, it is pointing to the very bottom. This is my first place to be writing. I'm writing 1. After I write 1, what will happen? After you write 1, my right pointer will point to the next available data. So it will go up 1 place, and I have here 1. My read pointer is still at the same spot. It didn't read anything. Okay? Now I'm gonna write 0. After I do that, what will happen to the right pointer? It will go up here. I have here 1, 0. And I'm ready to write what is coming next. What will happen if instead of writing anything, I am reading? I am reading. What will happen if I read? I am going to read 1. But what will happen to the read pointer? The read pointer will go up 1 slot. And it has read already this one. Hello, Bernard? Bernard?
Yes, Professor.
My next step is to write. So I am going to write here 1. Where would the right pointer go?
It will go to the next
Next
box above.
So if I am here and I have here 1, 0, I have nothing at the bottom because I read it already. So it is not here. And the read pointer is here. And I wrote this one. So my right pointer is right in here. And in this step, I am gonna write another 1. And if I write another 1, hello, Paige?
Hello, Professor.
If after writing this 1, where the right pointer will go? We wrote this 1. Where the right pointer will go?
To the right? Or, sorry, can you clarify your question?
I have just written at this spot according to the right pointer 1. And the right pointer should point to where it is going to write if there is another right statement. Where should it point to?
Oh, there should be another one going to the right, correct?
I don't have any right. I have up and down now.
Cover it. Okay, then it's going up.
Okay, it's going up. So it will go up 1 slot. This one has nothing now. I have 0, 1, 1. And my right pointer is here. And my read pointer is here. Vitaly?
Yes, Professor.
If I have another read, what will it read?
Let's see, the last one you said you wrote was 1, right?
I am speaking about my read, not write. I
The
have
next one,
2 pointers, one for write and one for read. If I want to read, what will I read?
the next bit, which I think is 1.
Can you see the read pointer? Where is it?
Are you speaking about the one on the very far right? The blue
The
column?
read R. Read, this read. This is my read.
Mm-hmm.
Where it is pointing at.
Oh, okay, pointing to 0 right now.
So it's going to read 0.
I see, because it hasn't been read yet. That's gonna be the next one.
Yes,
Okay.
that
Yeah,
is
that's
where
gonna
my
read 0.
read pointer is residing. It is residing on where to read.
I see what you're saying.
And after I read this, where the read pointer will go. After reading the 0, where the read pointer will go.
Probably gonna go up 1, right? So it's
It
gonna
will
read the
go
1
up
next.
1. It will go up 1.
I see. So it keeps going up every time it's read something?
Yep.
Okay.
So the read pointer, after I read this 0, I have here nothing. It will go up 1. And I have here my right pointer. I have here, oh, the right pointer is 1 step down. It's right here. No, it is up, yes, because read the 1, sorry. Now, if you have noticed that what was the first data that came in? What was the first data that came in? It was this one. And after this one, I added 0. And when I decided on reading, what was the first thing to read? I started from the bottom. I read 1. 1 was the first data entry. And when I started reading, I started with this one. So that is why we call it the first in. It was the first to come out. First in will be the first to come out. And I kept on adding data. And as I add data, the right pointer will go up. And as I read data, the read pointer will go up. What will happen if I reach the topmost? Writing, I wrote every element. If I reach the full array, I will get, of course, a warning. I cannot write anywhere. I finished. So I need to reset my right pointer all the way down. And the same thing for read. If I'm reading, I have nothing to read. If I have here at this point, if I read 1 and then 1, there is nothing written if I want to read one more thing. It is empty. So I will get another warning. This is shown right in here. This is my read and write pointer. Both are pointing to memory location 0. If I write something to memory location 0, the right pointer will be advanced to 1. If I have, this is after 1 write. What will happen if I add 3 more writes? 1, 2, 3. My right pointer will be at 4. Please remember, I didn't read anything, so the right pointer is still at the same spot. Now, if I have one read, it will advance. 4 more reads, 4 more writes. Can you see? I was here at 4 with 4. I put 1, 2, 3, 4. I advanced 4 and I am here. I am back to memory location 0. If there is data that I didn't read and I am here, I am going to overwrite it. Here, one more write. So I am at point 1, memory location 1. What will happen if I have to read? Those two memory locations are read and empty. But with this one, I have overwritten whatever was on memory location 1. I have overwritten whatever was on memory location 1. So read will point to the next spot to read. If there is data, it will be overwritten. Here, I have to read, so I am at point 3. 5 more reads. Can you see 5 more reads? I'm here. 1, 2, 3, 4, 5. And 2 reads, 5 plus 2, that is 7. I was here, 1, 2. Then 3, 4, 5, 6, 7. I am here after 5 more reads. 1 more read, I am reading whatever was there. It could be empty. Let's repeat that one more time, but this time you will be helping me. Jose? Jose?
Yes, Professor.
Let's start from the beginning. Right now, my read and write pointer are both at memory
0.
location 0. After one write, where the write will be, the right pointer?
That will be a 1.
That's here. What about the read pointer?
That will be a 0, Professor.
Because I didn't read anything. I just issued a write command, so I wrote something in memory location 0, that's why it is dark, and I am pointing here. Still with me? One more time.
Yes.
I have 3 more write command. I was at 1. Where should I be after writing 3 memory locations?
That will be a 4.
I was here. I filled up 1, 2, 3. So my next target will be 4. Thank you.
You got it.
Jim?
Yes,
We
Yes.
are at this stage, C, figure C.
I'm too far from the computer. You answer. You can see it.
Okay.
Are you here, Cameron?
I'm here.
Okay. I am at C. If I want to read, where the read pointer will go?
If you want to read 3, is that what you said? I couldn't quite hear you.
I am at C. I'm gonna issue 1 read command.
Okay, then you'll read a 0 and you'll end up at 1.
Yes, I have read the 0 memory location. That's why it is empty. And my pointer has advanced from 0 to 1. Now I am at the page. Hello, page.
Hello, Professor.
We are at D. If I issue 4 write commands, where the right pointer will go? We are here. I issued 4 write commands. Where the right pointer should be?
I'm not quite sure.
Whenever you issue a write command, the right pointer advances.
Okay, so 5.
We issued 4. I
5.
was here. I issued 4. So this one will be filled. And this one will be filled. This one will be filled. This one will be filled. What will be, where will be the right pointer?
0.
Excellent. It will be here. Excellent. It will be here.
Professor, some of us have class at 12.
You have a class at 12?
Yes, so I'm going to head out.
Sorry. I
No
am
worries.
over the time. No. Sorry. Okay, everyone, we'll continue tomorrow. Thank you all. Sorry again. Sorry.
No
Bye-bye.
worries. Thank you.
Thank you. Bye-bye.
See you,
Thank you,
Professor. Have a
Professor.
wonderful day.
Thank you. Thank you all.